Hello, my name is Tiago, and I'll present this work called A Surprisal Duration Trade-off Across and Within the World's Languages. This was joint work with Clara, Liz, Simone, Damián, and Ryan. So as a quick highlight of this paper, we analyzed 600 languages. We found evidence of a surprisal duration trade-off, both cross-linguistically and within 319 of the analyzed languages. And we conclude that less surprising fonts are produced faster on average. So as a motivation for our paper, although natural languages differ considerably from one another, we may predict human cognition constraints how they are implemented. And these constraints may lead to compensations and trade-offs in the both across and within natural languages. In this particular paper, we assume a roughly constant channel capacity in humans' ability to process languages. This, in turn, leads to predictions both within and across languages, as I said before. So within languages, we predict that speakers should spend more time on highly surprising fonts and speed up on less surprising ones. And when I say surprisal, I mean the font's negative log probability, so minus the log of the probability of the font, given the previous fonts in the same sentence. So this means that speakers can control their speech rates to smooth an utterance's information rate, keeping it roughly constant near the channel capacity. If you're above the channel capacity, you can slow down because being above the channel capacity leads to miscommunication. While if you're below the channel capacity, you can speed up, meaning that you will waste less time and less effort in your speech. So this theory is directly connected to the uniform information density hypothesis. And in fact, it's one of its main interpretations, which says that speakers are trying to maximize the channel capacity. And if you're interested in this and other interpretations of UID, check out another paper discussing them, which is called Revisiting the UID Hypothesis. And it's also being presented here in the EMNLP. So we can also make predictions across languages. So we predict that there should be a cross-linguistic trade-off. Languages with more surprising fonts should have slower productions, while languages with less surprising fonts should have faster productions. So languages will trade off information content in terms of bits per font and utterance speed in terms of the seconds it spends per font. And this is an instantiation of the compensation hypothesis, where languages are compromising reliability in terms of information content versus effort in terms of the time they spend per utterance. In our analysis, we'll focus on the Vox Clementes dataset, which is based on spoken readings of the Bible and spans more than 600 languages from 70 language families. This dataset contains 9,000 utterances or 20 hours of speech on average per language, making it the largest dataset of its kind. Vox Clementes, though, is automatically generated, and in its production process, they use grapheme to phoneme models to go from the Bible's graphemes to phonemes. And this can introduce noise, so they made available the data sets with 3 different sets of G2P models, and we focus here on 2 of them. The first one is Epitran, which is composed of high-quality G2P models based on language-specific rules. And this data set is available for 39 dialects. And when we say dialect, this term refers to a dialect as recorded in a specific document. And 29 languages from 8 language families. The second set of G2P models is Unitran, which is a naive and deterministic G2P model, which is available for all languages in Vox Clementes. Since this data set is noisier, we filter out languages with lower quality alignments. And if you want more details, you can check out the paper for this. So this data set will be available for 647 dialects, 600 languages, and 69 language families. The trade-off that we want to analyze here, the surprisal duration trade-off, could arise though for other reasons that we're not interested in this work. So, for example, marked phones are known to be both longer and less frequent cross-linguistically. Being less frequent, they are on average more surprising. So if we don't control for this, we might find a trade-off that simply reflects the fact that this markedness of the phone will be related to both its length, its duration, and its surprisal. Another potential confound is that word initial phones are both longer and more surprising. So we must control for these things. Which we do in our analysis. And we discuss our design choices in more details in the paper as well. So going into our analysis, we first perform an analysis per each individual language within languages. And for this, we train the mixed effects model to predict a phone's duration from its surprisal for each individual doclet that we had. And this is the equation that we use for a mixed effect model in LME4 notation. So you can see in this equation that we control for word initial lengthening effects using a fixed effects term here. And we controlled for articulatory cost differences across phones by using random effects for each phone. We also control for the fact that durations are left skewed in the sense that they can't be negative by modeling them with a log normal distribution instead, which basically means that we log the durations before adding them to this model here. And then we are interested here in this surprisal term. So if the slope for this surprisal term is significantly positive, then it means that there's a trade-off between surprisal and duration, and that higher durations will imply in higher surprisals will imply in higher durations. And just as an aside here, since we log the duration here, a positive slope for the surprisal term won't be reflected in an additive effect into the duration, but actually in a multiplicative one, meaning that adding 1 bit of surprisal will actually multiply duration by 1.x. So this will be reflected in the plots that we'll show. So after training this model in each individual language, we found statistically significant positive slopes in Abtran in 30 out of the 39 doclets, and in Unitran in 326 of the 647 doclets, which is more than half. Furthermore, no language had a statistically significant negative slope, which gives us strong evidence that there is indeed a trade-off within languages. Here is the plot of the slopes per language for both Unitran and Epitran, and you can see the majority of them is above the 1.0 line, meaning that the trade-off is positive. This multiplicative trade-off is positive. And the few ones that are below it are not significantly, statistically significant. The second study that we ran was an aggregated cross-linguistic analysis. So in this study, we again predict duration from surprisal, but we trained a single model using data from all languages. And this is the mixed effects model we used, which is pretty similar to the one before, but we add some random slopes per language, and we make the random effects of the phones language specific. So one random effect per language per phone. And when we run this analysis, we again find a significantly positive surprisal slope. So here's the plot for Eptran of the fixed surprisal effect as the orange line, and the fixed plus the random effects per language for each individual language as the dots in this plot. And again, most of them are above the 1.0 line, meaning that there is a trade-off happening there. Finally, for our last experiment, we tried to run a purely cross-linguistic trade-off analysis. So in the previous model, we were running a cross-linguistic analysis, but we had a language-specific random effects. So that model could capture within language trade-offs and compensate for cross-linguistic differences with those random effects. What we do here is that we again predict duration from surprisal cross-linguistically, but we now average surprisals and durations per language for each found position tuple before training the model. So we're left with this model, which is pretty similar to the first one, but the duration is not logged now because since we average surprisals and durations per language before training the model, by the central limit theorem, we have that the durations should be roughly Gaussian. So after training this model, we again find a significantly positive surprisal slope. So to conclude, both across and within languages, founds carrying more information are longer, while founds carrying less information are produced faster. And we find this consistently in a number of different experiments. And this is it for our presentation. Thanks for watching. And I hope you come to our oral session here in EMNLP. And I'll see you virtually in the conference.